NEMA connectors are AC power plugs used for mains electricity in North America and other countries that use the standards set by the U.S. National Electrical Manufacturers Association. NEMA 5 Euro 15 is the standard electricity outlet found in almost every household and building in the United States. Similar and interchangeable connectors are used in Canada and Mexico. NEMA wiring devices are made in current ratings from 15 to 60 amperes, and electrical potential ratings from 125 to 600 volts. Different combinations of contact blade widths, shapes, orientation, and dimensions give non-interchangeable connectors that are unique to a particular voltage, current capacity, and grounding system. NEMA 1 and NEMA 5 are used for commonplace domestic equipment. The others are for heavy-duty or special purposes. The dimensional standard for electrical connectors is ANSI NEMA WDA Euro 6 and is available from the NEMA website. NEMA nomenclature. There are two basic classifications of NEMA device, straight blade and locking. The straight blade 5 Euro 15 and 5 Euro 20 are found nearly everywhere in countries using the NEMA standards, and are intended for supplying lighter-duty, general-purpose electrical devices. Twist-locking types are used for heavy industrial and commercial equipment, where increased protection against accidental disconnection is required. Numbers prefixed by LR curved blade, twist-locking connectors. Others are straight blade and non-locking. The metal conductive blades are sometimes informally called prongs. The numeral preceding the hyphen in NEMA nomenclature indicates the configuration, that is, the number of poles, number of wires, voltage, and whether single or three-phase. A grounding type of device is described as 2-pole, 3-wire, or 4-pole, 5-wire, etc. A non-grounding device may be 2-pole, 2-wire, or 3-pole, 3-wire, etc. The numeral following the hyphen is the rating of the device in amperes. The number is followed by the letter R to indicate a receptacle or the letter P to indicate a plug. As an example, the 5 Euro 15 is the common 125 V 2-pole, 3-wire receptacle. The L5 Euro 15R, while sharing the same electrical rating, is a locking design that is not physically compatible with the straight blade 5 Euro 15 design. The 5 Euro 30 has the same 2-pole, 3-wire configuration and 125 V rating, but is rated 30A. Although there are several non-grounding device types in the NEMA standards, only 3 of them are in widespread use today. These are the 2-pole 1 to 15, still in use in millions of buildings built before the 1960s, and the 3-pole 10 Euro 30 and 10 Euro 50. The small hole near the end of the power blades of some NEMA plugs is used for convenience in manufacturing. If present, it must be of specified diameter and position. Small specialized padlocks are available to fit these holes, allowing lockout of hazardous equipment, by physically preventing insertion of locked plugs into a power receptacle. Blade identification. The blades of a NEMA connector are identified with non-locking connectors. NEMA non-locking connectors all use blades of various flat and folded shapes. The plugs can be detached from the receptacles by pulling back on the plug body. These connector families have been designed so that grounding connectors for 120 V and 208 240 V cannot be accidentally intermated. NEMA wall receptacles can be found installed in any orientation. Neither NEMA nor the U.S. National Electrical Code nor the Canadian Electrical Code specify a preferred orientation, and different orientations may be found in the same building. When the ground blade of a receptacle is on the bottom, the neutral blade is on the upper left and the hot blade is on the upper right. All descriptions below assume this orientation. NEMA 1. This 2-prong plug and socket design, with 2 flat parallel non-coplanar blades and slots, is used in most of North America and on the east coast of South America on lamps. Consumer electronics such as clocks, radios, and battery chargers, and other double-insulated small appliances that don't require grounding. All NEMA 1 devices are 2-wire non-grounding devices rated for 125 V maximum. NEMA 1-15P plugs have two parallel flat blades, one a 4-inch wide, 0.06 inches thick, 5/8 Euro-23 a 32-inch long, and spaced one a 2-inch apart. Ungrounded NEMA 1-15 sockets have been prohibited in new construction in the United States and Canada since 1962, but remain in many older buildings, and this obsolete design is still available for repair use only. Since January 1, 1974, all new power outlets are required to have a ground connection, using grounded sockets that accept both grounded and non-grounded plugs. Replacement of obsolete NEMA 1 receptacles requires either an NEMA 5, or an NEMA 5 GFCI for two-wire non-grounded configurations. Ungrounded NEMA 1 plugs are still popular with manufacturers for certain applications, because of their low cost and compact size. They are upward compatible with widely available grounded NEMA 5 receptacles. Standards permit ungrounded plugs where the appliance does not require grounding due to low risk of leakage current, such as on double-insulated devices. In older plug designs, both blades were the same width, so the plug could be inserted into the socket either way around. Many plugs manufactured since 1948 are polarized. The neutral blade is wider than the line blade, so the plug can be inserted only one way. Polarized NEMA 1-15 plugs will not fit into unpolarized sockets, which possess only narrow slots. Polarized NEMA 1-15 plugs will fit NEMA 5-15 grounded sockets, which have a wider slot for the neutral blade. Some devices that do not distinguish between neutral and line, such as internally isolated electronic power supplies, are still produced with unpolarized narrow blades. Cheetah plug adapters allow a 3-prong grounded NEMA 5-15 plug to be mated to a non-grounded NEMA 1-15 socket. The adapters include a spade lug to allow connecting to ground, often via the cover screw used to attach the socket faceplate. NEMA standards exist for 1 Euro-15P, 1 Euro-20P and 1 Euro-30P plugs, and the 1 Euro-15R receptacle. There are no 1 Euro-20R and 1 Euro-30R receptacles, because 1 Euro-20P and 1 Euro-30P can mate with a corresponding NEMA 5 receptacle. NEMA 2 All NEMA 2 devices are two-wire non-grounding devices rated for 250 V maximum. Although standards exist for 2 Euro-15, 2 Euro-20 and 2 Euro-30, this series is obsolete, and only Hubbell still manufactures 2-20 devices. NEMA 5 All NEMA 5 devices are three-wire grounding devices rated for 125 V maximum, with the 5 Euro-15, 5 Euro-20 and 5 Euro-30 being grounded versions of the 1 Euro-15, 1 Euro-20 and 1 Euro-30, respectively. The addition is a 3/16-inch diameter round or U-shaped ground pin, 1/8 in longer than the power blades and located below them by 1/4 in edge-to-edge or 15/32 in center-to-center. Compared to the 5-15P plug, the 5 Euro-20P plug has the neutral blade rotated 90 degrees and shifted so its inner edge is approximately 1/2 in from the hot blade. The 5 Euro-20R receptacle may have a T-shaped neutral hole, to accept both 5 Euro-15P and 5 Euro-20P plugs. The 5 Euro-30 and 5 Euro-50 are larger, with 1 inch between power pins. 5-30 also has a bent neutral blade. All of these are uncommon, as twist-locking plugs are generally used for high-current applications. Both current blades on 5 Euro-15P plugs are nearly always narrow since the ground pin enforces polarity. If the ground pin is removed to make it fit a 1 Euro-15R outlet or extension cord, the line neutral polarity is lost. 1 Euro-15P plugs are also compatible with 5 Euro-15P sockets. In this case, the socket retains polarity enforcement. Cheetah plugs, adapters that make a 5 Euro-15P plug fit a 1 Euro-15R outlet, are readily available and retain line neutral polarity, but are illegal in some countries such as Canada. Proper grounding is dependent on the outlet being an ordinary duplex receptacle with a correctly grounded center screw, and the grounding tab of the adapter being connected to that screw. The 5A-15A is by far the most common electrical outlet in North America in buildings built since the mid-20th century. It is usually installed in a twin duplex configuration. The usual orientation in residential buildings is with the ground pin on the bottom, while in commercial or institutional buildings this pin is on top, per National Electrical Installation Standards. Sideways installation is also permitted. In this case, NECA 130/2010 specifies the neutral pin is on top. In 46 of the 50 United States and all of Canada, tamper-resistant sockets are required in new residential construction as of November 2013. These prevent contact by objects like keys or paper clips inserted into the socket. In stage lighting for film and theater, this connector is sometimes known as PBG, Edison or Hubbell, the name of a common manufacturer. In the motion picture and TV production industries, an extension cord that uses this type of connector is called a stinger. Generally, lighting technicians use these extension cords to deliver power to lights rated at 2000 W or less. NEMA 6 – All NEMA 6 devices are 3-wire grounding devices used for 208 V and 240 V circuits and rated for 250 V maximum, with the 6A-15, 6A-20 and 6A-30 being grounding versions of the 2A-15, 2A-20 and 2A-30, respectively. The 6-15 resembles the 5-15, but with collinear horizontal pins, spaced 23A-32A and center-to-center. The 20A plug has a blade rotated 90 degree, and the 6A-20R receptacle may have a T-shaped hole, to accept both 6A-15P and 6A-20P plugs. 6-15R and 6-20R receptacles are usually manufactured on the same assembly line as industrial, or commercial grade 5-15 and 5-20R receptacles, with all four receptacles sharing the same triple wide T contacts behind the varying faceplates. The faceplate bonded onto the receptacle determines the final configuration of the receptacle. The 30A plug and socket look similar to the 15A one but larger. The higher current versions are rare, with twist-locking plugs such as L6-30 or direct wiring more common. Generally 6A series non-locking plugs are used for such appliances as large room air conditioners, commercial kitchen equipment, and the occasional home arc welder. Single-phase 6-50 is commonly used on farms for the silo unloader, and is used with a 6-gauge flexible power cord up to 200 ft long. NEMA 6 devices, while specified as 250 V, may be used for either 208 V or 240 V circuits, generally depending on whether the building has a 3-phase or split-phase power supply, respectively. The NEMA 6A-20 or 6A-30 found in many hotel rooms is often supplied with 208 V and without a neutral. NEMA 7 devices are 3-pin connectors rated at 277 volts. A 15-amp 7-15 plug has the crowsfoot current-carrying pins of the Type I plug, but with a U-shaped earth pin. The 7-20 version has an enlarged neutral pin. 7-30 is a larger diameter connector, with an L-shaped neutral, while the 7-50 has an enlarged neutral pin, compared with the hot. NEMA 10 NEMA 10 devices are a curious throwback to an earlier time. They are classified as 125/250 V non-grounding, yet they are usually used in a manner that effectively grounds the appliance, though not in a manner consistent with most modern practice. As commonly used, 10A-30 and 10A-50 plugs have the frame of the appliance grounded through the neutral blade. This was a legal grounding method under the National Electrical Code for electric ranges and electric clothes dryers from the 1947 to the 1996 edition. Since North American dryers and ranges have certain parts that run on 120 V, this means that the wire used for grounding is also carrying current. Although this is contrary to modern grounding practice, such installations remain common in the United States and are relatively safe, because the larger conductors used are less likely to be broken than the smaller conductors used in ordinary appliance cords, and the current carried on the neutral conductor is small. NEMA 10 Euro 20 devices are very rare nowadays, but are occasionally found in homes that once had a large window air conditioner. NEMA 14. The NEMA 14 devices are 4-wire grounding devices available in ratings from 15A to 60A. Of the straight-blade NEMA 14 devices, only the 14 Euro 30 and 14 Euro 50 are common. The 14 Euro 30 is used for electric clothes dryers and the 14 Euro 50 for electric cooking ranges. The voltage rating is 250 V. They are essentially the replacements for the NEMA 10 connectors above with the addition of a separate grounding connection. All NEMA 14 devices offer two hots, a neutral and a ground, allowing for both 120 V and 240 V. The 14 Euro 30 has a rating of 30A and an L-shaped neutral blade. The 14 Euro 50 has a rating of 50A and a straight neutral blade sized so that it does not fit in the slot of a 14 Euro 30. NEMA 14 Euro 50 devices are frequently found in RV parks, since they are used for shore power connections of larger recreational vehicles. Also, it was formerly common to connect mobile homes to utility power via a 14 Euro 50 device. Newer applications include Tesla Motors' mobile connector for vehicle charging, which recommends the installation of a 14 to 50 receptacle for home use. NEMA TTA Euro 30. NEMA TTA Euro 30 is a 30A, 125V recreational vehicle standard, also known as RV30. It is frequently confused for a NEMA 10 Euro 30. The RV receptacle is common in nearly all RV parks in the United States and Canada, and all but the largest RVs manufactured since the 1970s use this plug. The hot and neutral blades are angled at 45 degrees from vertical and 90 degrees to each other, similar to NEMA 10 devices. The plug is slightly smaller than NEMA 10 but larger than ordinary 5 Euro 15 plugs. The ground pin, however, is round, like those on straight-blade NEMA grounding devices. Referring to the diagram, the orientation is the same as the NEMA 5 plug and socket, with the receptacle neutral on the lower right. The appearance of this plug makes many people assume it is for 240 V, but this is a 120 V device. Adapters exist with the TTA Euro 30 plug on one side and a 5 Euro 15 or 5 Euro 20 socket on the other side. When the cord is detachable from the RV, an L5 Euro 30 is usually used on the RV end of the cord. Twist locking connectors. Twist locking connectors were first invented by Harvey Hubbell III in 1938 and twist lock remains a registered trademark of Hubbell Incorporated, although the term is used generically to refer to NEMA locking connectors manufactured by any company. Locking connectors use curved blades. Once pushed into the receptacle, the plug is twisted and its now rotated blades latch into the receptacle. To unlatch the plug, the rotation is reversed. The locking coupling makes for a more reliable connection in commercial and industrial settings, where vibration or incidental impact could disconnect a non-locking connector. Locking connectors come in a variety of standardized configurations that follow the same general naming scheme except that the designations include an L for locking. Locking connectors are designed so that different voltages and current ratings cannot be accidentally intermated. Many specific types exist. Only a few are listed below. Other types include special-purpose connectors for boats, 400 Hz circuits such as used for aircraft, and direct current applications. One apparent disadvantage of twist-lock connectors is that in the event that the cable is accidentally pulled too hard, rather than the plug falling out of the receptacle, the exposed conductors may come out of the plug, causing dangerous shorts or shock hazards if the circuit is live. This is resolved in most cases by the connector having an integral strain relief. NEMA MIL1 NEMA MIL1 connectors are a series of midget locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS. No grounding conductor is provided. NEMA MIL2 and NEMA MIL2 connectors are a series of midget locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS. A separate grounding conductor is provided. NEMA MIL3 and NEMA MIL3 connectors are a series of midget locking connectors with a maximum specified voltage of 250 V. Supply connections are intended for two-pole hot neutral circuits with a nominal voltage of 120-240 V RMS. No grounding conductor is provided. NEMA L5 NEMA L5 connectors are a series of locking connectors with a maximum specified voltage of 125 V. Supply connections are intended for single-pole hot neutral ground circuits with a nominal voltage of 120 V RMS. NEMA L6 NEMA L6 connectors are used with circuits with a maximum specified voltage of 250 V. Supply connections are intended for two-pole, three-wire hot ground circuits with a nominal supply voltage of 240 V or 208 V, depending on phase configuration. The L6 connector does not provide a neutral connection. L6-20 and L6-30 connectors are commonly found on in-rack power distribution units in countries where the main supply voltage is greater than 120 V. They are also found in the US for heavy-duty 240 V equipment such as welders, where the higher supply voltage allows a lower current draw. These connectors are thus found where industrial equipment or large power tools are commonplace. NEMA L7 NEMA L7 connectors are used with circuits with a maximum specified voltage of 277 VAC. Supply connections are intended for single-pole, three-wire hot neutral ground circuits with a nominal supply voltage of 265 V. Typically, these connectors are found in commercial or industrial lighting circuits, especially where metal halide lamps are common. NEMA L8 NEMA L8 connectors are used with circuits with a maximum specified voltage of 480 VAC. Supply connections are intended for two-pole, three-wire hot ground circuits with a nominal supply voltage of 460 V. NEMA L9 NEMA L9 connectors are used with circuits with a maximum specified voltage of 600 VAC. Supply connections are intended for two-pole, three-wire hot ground circuits with a nominal supply voltage of 600 V. NEMA L14 NEMA L14 connectors are used with circuits with a maximum specified voltage of 125-250 V. Supply connections are intended for two-pole, four-wire hot neutral ground circuits with a nominal supply voltages of 240 V or 208 V hot to hot and 120 V hot to neutral. These connectors are common on household backup generators, and on racks of power amplifiers in large audio systems. NEMA L15 NEMA L15 connectors are used with circuits with a maximum specified voltage of 250 VAC. Supply connections are intended for three-phase, four-wire LLG circuits with a nominal supply voltage of 208 VLL or 240 VLL. NEMA L16 NEMA L16 connectors are used with circuits with a maximum specified voltage of 480 VAC. Supply connections are intended for three-phase, four-wire LLG circuits with a nominal supply voltage of 480 V. NEMA L17 NEMA L17 connectors are used with circuits with a maximum specified voltage of 600 VAC. Supply connections are intended for three-phase, four-wire LLG circuits with a nominal supply voltage of 600 V. NEMA L18 NEMA L18 connectors are used with circuits with a maximum specified voltage of 120-208 VAC. Supply connections are intended for Y3-phase, four-wire LLN circuits with a nominal supply voltage of 208 VLL and 120 VLN. NEMA L21 NEMA L21 connectors are used with circuits with a maximum specified voltage of 120-208 VAC. Supply connections are intended for three-phase, five-wire LLNG circuits with a nominal supply voltage of 208 VLL and 120 VLN. These three-phase connections include neutral and ground. The pin in the middle is ground, and the blade with a right angle on the tab is neutral. NEMA-L22 NEMA-L22 connectors are used with circuits with a maximum specified voltage of 277/480 VAC. Supply connections are intended for three-phase, 5-wire LLLNG circuits with a nominal supply voltage of 460 VLL and 265 VLN. NEMA-L23 NEMA-L23 connectors are used with circuits with a maximum specified voltage of 347/600 VAC. Supply connections are intended for three-phase, 5-wire LLLNG circuits with a nominal supply voltage of 600 VLL and 347 VLN. Special safety features. Over time, electrical codes in the US and Canada began to require special safety features in the basic NEMA 5-15 and 5-20R configurations to address specific electric shock hazard concerns. The safety features listed below are not mutually exclusive. Tamper-resistant GFCI receptacle outlets are sold. Ground fault circuit interrupter receptacles. These versions of the 5-15 or 5-20 receptacle are residual current devices and have test and reset buttons. In the US and Canada, they are required in many potentially wet locations, including outside outlets, bathrooms, some places in kitchens, basements, and crawl spaces. They work by comparing the current going out on the hot conductor to the current returning on the neutral conductor, and disconnect the circuit if the difference exceeds 4 €6 mA. They are cheaper than GFCI circuit breakers and can be wired to feed additional downstream outlets so that putting one GFCI receptacle in a circuit protects all the plugs, lights, and switches downstream from it. They are also recommended for power tool outlets and locations where children might insert conductive objects into the receptacles. Tamper-resistant receptacles, starting with the 2008 National Electrical Code and the 2009 Canadian Electrical Code, listed tamper-resistant receptacles that address electric shock hazards to children must now be installed in almost all areas of new or renovated dwellings. According to statistics cited by the NFPA, the code change adds only $40 to the cost of building an average, 75 receptacle home in the U.S., yet prevents shock hazards to a child that sticks a single, metal object into the receptacle. The new receptacles are expected to reduce the number of electric shocks to children because inserting a normal, two-prong electrical plug applies pressure on both sides of the outlet to open an internal, spring-loaded shutter, but a foreign object fails to do so and therefore does not make contact with the live electrical contacts. However, the device can still be defeated by inserting two objects simultaneously. Despite its weaknesses, the tamper-resistant receptacle is superior to protective plastic outlet caps which must be individually installed on each receptacle, and to sliding covers that children easily learn to defeat. Leak current detection and interruption plugs. Because portable air conditioners have caused many electrical fires, those sold in the United States now must have leak current detection and interruption plugs. The cords have a fine wire mesh around the conductors and circuitry to detect any current leaking from the conductors to the mesh, which would happen if the cord were damaged or frayed. These could be NEMA 5-15, 5-20, 6-15, 6-20 or 6-30 plugs, depending on the air conditioner. The plug is equipped with test and reset buttons on the housing. Color code: the color of a device neither identifies its voltage class nor power system. Because the colors are not identified by national standards, the purpose of color coding a receptacle is set by the building owner. In this case, building owners may select brown, ivory, white, almond, gray, and black receptacles in the 5-15 configuration to blend with the decor of a room. However, although colors are not standardized by NEMA, some industries utilize colors for certain applications. Following de facto standards, blue receptacles may indicate built-in surge suppressors. A red receptacle may indicate a special service outlet such as one connected to an emergency standby power source. At least one manufacturer makes a yellow receptacle, which identifies it as corrosion resistant. An orange receptacle is an isolated ground receptacle. A receptacle with a green dot is a so-called hospital-grade device. Such devices are tested to survive harder use than wiring devices intended for residential or commercial purposes. A receptacle with an orange triangle is an isolated ground device, where the grounding pin of the receptacle is connected to ground independently of the frame of the receptacle and wiring outlet box. The receptacle itself may be any color, though older common convention in the United States specified an orange receptacle rather than an orange triangle on the receptacle. Breakaway tabs. Duplex receptacles have breakaway tabs to separate the top and bottom outlets, so that they can be wired onto separate circuits. This may allow for one switched outlet for a lamp, or for two circuits when heavy loads are anticipated. Two branch circuits may optionally share a common neutral terminating on duplex receptacles, a condition sometimes referred to as split wiring, split receptacle, or half split. Neglecting to break the tabs when replacing a split receptacle can disable a switched outlet, or cause a short circuit, or accidentally parallel two circuits, depending on how the receptacle had been wired. Obsolete devices. Original Hubbell plug and receptacle. An early American electrical plug and socket was invented by Harvey Hubbell and patented in 1904. Hubbell's first design was a socket which screwed into a lamp holder, but with a separable plug with pins or blades. The 1906 Hubbell catalog shows this plug with a flush mounting socket for use in wall or floor. Other manufacturers adopted the Hubbell pattern, and by 1915 they were widespread. American 125V, 15A/250V, 10A Australian style. A patent for this obsolete plug and socket was filed in 1915 under U.S. Patent 1,179,728. It predated the NEMA sockets and plugs, but is similar to NEMA 10-20. The plugs and sockets used in countries such as Argentina, Australia and China are based on this type. NEMA 1-15 style 5 receptacle socket. This is a 5-way socket from c. 1928, and is able to accept modern ungrounded polarized NEMA 1-15 plugs. The socket is obsolete, as the current NEMA standard only allows a maximum of 3 sockets in a single receptacle unit. NEMA 1-15 light switch style socket. This is a rare light switch style 1-15 outlet. It has one vertical socket, and it can accept modern ungrounded NEMA 1-15 plugs. It is obsolete as it has little insulation, thus is a minor fire hazard when used with high wattage devices. Related standards. The dimensions and configurations for NEMA connectors are given in ANSI NEMA standard WD6. Underwriters Laboratories maintains UL standard 498, which specifies construction performance for NEMA connectors. These additional requirements allow connectors to be manufactured to be compliant with the National Electrical Code. The Defense Logistics Agency and General Services Administration maintain Federal Specification WC596 and its associated specification sheets. This specification references WD6 and UL 498, and provides additional durability and electrical safety performance criteria for connectors intended for military use. See also. References. External links, NEMA chart at mahornkeen.com, NEMA chart at generatorjar.net.